In this video, I'm just going to talk about what happens when an access point, uh, for some reason, is the root bridge, not the core switch. So I have a topology here, um, pretty simple topology. I have a core and I have uh, three access switches, switch 1, switch 2, and switch 3. So currently, core is actually the root bridge, and we can verify that by just doing show VLAN 10. And we see that this switch is actually it's actually the root bridge, as it says here. This bridge is the root, so at least for VLAN 10, and it's actually the root bridge for all the VLANs configured on this switch. So we have VLAN 10, 20, 30, and 40. So I'm going to simulate and um, just make switch 1 as the root bridge. So let me actually do that command again. Oops, actually just show spanning tree. Just show you all the VLANs. So here, uh, VLAN 1, this is the root bridge. This bridge is the root. And VLAN 20, this bridge is the root. And VLAN 30, this bridge is the root. And VLAN 40, this bridge is the root. And if you check the ports, all the ports that are connected to it, gig 0 slash 1, gig 0 slash, gig 0 slash 0, gig 0 slash 1, and gig 0 slash 2, these ports should be in designated, I mean, these ports should be designated ports and all in forwarding state. So let's check VLAN 40. So as you can see here, gig 0 slash 0 is designated forwarding. 0 slash 1 is designated as well in forwarding, and that's connected to switch 2. And gig 02 slash 2 connected to switch 3 is also designated and forwarding. So spanning tree is working as expected. Let me actually go to switch 1 and just do the same command. So here, let's say VLAN 30. So this is the root priority, root ID. So root ID is actually, so root ID is composed of priority and uh, MAC address. And if we go back to the uh, core switch, the address is this, so same. And here, the bridge ID of switch 1 is this one. So it says here that um, the priority of switch 1 is this one, and MAC address is this one. And if we go back and if we check the role of the port, this is the one connected to the core switch, right? So gig 0/0. So the role is root and it's in forwarding state. Okay, and this is all the same for all the access switches actually. So if we do the same command, let's say this time for /20, I mean VLAN 20. So the root port is this one uh, because this is the one connected to the root bridge, gig 0/1, and of course it's in forwarding state. This should be the same for all the VLANs actually. So here, same. Let me just check switch 3 as well. So switch 3, let's check VLAN 10. So root port is gig 0/2, which is this one, and this it's in forwarding state. All right, so going back, um, like I said in the beginning of this video, I'm going to make switch 1 as the root bridge and core as a uh, as a secondary root bridge in this case. So I'm going to just copy this command. This is actually how you configure bridge priority of a VLAN, and you can see other configurations as well. So enabling and specifying STP mode, and now configuring the root bridge, secondary root bridge, and of course the verification commands. And it says here this note. I mean, I got this note from this document from cisco.com. So it says that the root switch for each instance of a spanning tree should be a backbone or distribution switch. You should not configure an access switch as the root as the spanning tree primary root. But yeah, just to simulate, we're going to do that in this video. So going back to switch 1, and of course let's just check the current configuration. So yeah, priority is this 8192. So I'm going to make it 9000, I mean 4096. So this will be the root bridge. And my mouse is acting up again. Okay, do the same command. Okay, and I'm going to the core switch. Make that core switch. I mean, make the priority of that core switch as this. So done. Spanning tree. Okay, done. Save and save. So let's check. Let's check switch 1. Going to do spanning tree VLAN 10. So it says here, this bridge is the root, and port, which is this one, gig 0/0, is in designated port, I mean role, and in its forwarding state. So working as expected. Let's check VLAN 20. So same, VLAN 30, same, VLAN 40. Okay, same. And let me go to the core switch and just do the same command. So it says here that before this port was designated port, but now it's root port because this port is the one connected to the root bridge here, switch one. So it should be this should be the same for all the VLANs. Yeah, root port in forwarding state. VLAN 30 the same. Root and forwarding state. In VLAN 40. Root and forwarding state. So yeah, so right now we know that switch one is the root bridge, which is not actually recommended, but we are just trying to simulate this kind of scenario and see if the network will still work. So I actually tried this earlier and I verified that it is still working. So here, going back to the topology, um, we have Ubuntu 1. It's in VLAN 20 and it's got an IP address of 10.20.20.2, and we have a printer in VLAN 30 and it's got an IP address of 10.30.30.3 and a server in VLAN 40 and has an IP address of 10.40.40.4. So let me go to Ubuntu one and see if I can ping. Let me just do ifconfig just to verify the IP address. So yeah, 10.20.20.2. Let me see if I can ping 10.40.40.4. Looks like I cannot. Unreachable. Okay. Unreachable. Let's check server for the server itself. You know what? Maybe these hosts are not working as expected, so I'm going to shut them and shut or power off and power on. Start, start, start. Let's go back to Ubuntu 1. Okay, about server. Okay, so Ubuntu 1 and server. Let me ping Ubuntu 1 actually. Looks like it's not working. So cat etc network interfaces. Mm-hmm. Let's check switch 1. VLANs are there. Gig 0/1. Oh yeah, this is the problem. So it looks like gig 0 switch port VLAN 20 done. For some reason that part was not saved. The port connected to printer is gig 0/2, gig 0/2, and it's got the same situation. This is in VLAN 30. Okay. And switch 3 is the port connected to server is gig 0/3. Gig 0/3, gig 0/3, gig 0/3. No, gig 0/3. Yeah, same situation. 0/3. Access VLAN 40, right? Save. And save, switch 1, save. Yeah. Let's try again. Let's try to ping server or Ubuntu 1 from server. Still not working. So, route. Yeah, it has a gateway, correct. How about this one? Yeah, correct. I mean default gateway and printer. How about printer? Route. Yeah. Uh, hmm. I have config. Yeah. So configurations, looks like configurations on the workstations or end hosts are correct. Let's check switch 1. Let's check this port. Okay, correct. Switch 2. Gig 0/1. Correct. Gig 0/2. Correct. And let's just check the VLANs as well. Correct. Okay, got VLANs. Correct as well. So configuration is looking good. Let me check if I can ping switch Ubuntu 1. I can ping it. Okay, that's good. Go to Ubuntu 1 and see if I can ping my gateway. I can ping my gateway. About oh, now I can ping it. So I think it's just took a couple of minutes for that config to take effect on those switches. So now I think I should be able to ping Ubuntu 1 from the server. Yes. and printer as well. Yes. Let me go to Ubuntu 1 and ping the server. It works. And the printer as well. So as you can see, even if switch 1 is the root bridge, the network still works. But this is actually not a recommended um, span and tree design, right? Like I said earlier, the root switch for each instance of a span and tree should be a backbone or distribution switch, not an access switch. So yeah, that's it in this video. I just wanted to uh, try it myself because I had this kind of situation before. So now we verified that the network will still works. And I think the reason is, you know, when switch one is even switch one is the root bridge, its ports are still in forwarding states, right? So uh, let's say for VLAN 10, so gig 0/0 is designated and it's in forwarding state, so it's still working. Let's check VLAN 20. So for VLAN 20, you can see here that 0 slash gig 0/1 is in designated, has a role of designated, and it's in forwarding state. And also note that endpoint stations are not aware of the spanning tree protocol in the network, right? So yeah. All right, that's it in this video. Thanks for watching.